Hey, what's going on, guys? Xiangqi is here. In this video I'm going for a quite pretty interesting experiment, well, at least to my mind. So I have a device which is an Arduino Nano with a custom 4x4 keys keypad and the LCD shield being connected to it, and I'm running a xiangqi emulator on this device. So xiangqi is a computer back from 1976 and it's programmed in 6502 machine codes. And here on the screen you see a custom implementation of a hex monitor that I've adopted from the original game, because in the original game we have 6, 7 segment LEDs, and I've adopted this to be displayed on this LCD display. So back in the day, as you might have already know this from the previous video on this channel, there were attempts to write even some sort of a video games on those 7 segment LEDs, and there was a program called HEXPAWN, which kind of made use of those 7 segment LEDs to kind of mimic the pawns. Like you just can watch that video. That's the previous video on my channel. I'll probably just give you a link in the description below just to give an idea how that kind of looked like. And I was even playing that game in the computer pad emulator, but anyway, so that's just kind of give you an idea of how that sort of look like. So yeah, here is the video for HEXPAWN. So I would just probably better just give a link in the description below. So that sort of a game has inspired me to make my own custom chess variant that would be possible to play on this LCD display. But as far as we don't have 8x8 like I don't know pieces, like places for to display the character, we only have 16x2. That's the reason to kind of minimize the size of the chessboard and amount of the chess pieces being involved and the rules. So literally we're going to be developing a new chess variant. I call it 2x8 chess. So this is going to be the family of so-called mini chess family. So there are many variants of so-called mini chess where you have just the less board squares and the less number, like less pieces, less piece types. So I've designed a sort of a game already. I'll just share this right in a moment. We're going to be developing this game absolutely from scratch. I'm going to be prototyping this in Python first because it's just fast, with an idea of later on actually putting this game like turning this game, rewriting this game in 6502 machine codes, not even assembly, but in 6502 machine codes, old school programming, and then running this on my device. So I could have just entered the from square and the two square, like source and destination squares from this keypad using just the digits and kind of playing the game of chess on this sort of a device. So if you're wondering, like, what about the real chess for xiangqi, there was one, and I also have a video on that, and that was, by the way, the world's first commercial chess program. It's written by Peter Jennings, and it was quite good at that time, and I don't really see much reason for writing another one, like, I don't know, playing stronger or taking less bytes. That's kind of possible, but it's not the scope of my interest, in at least currently. And what I've been trying to do instead, before actually making this xiangqi emulator, I had a custom CPU emulator before implementing this 6502 emulator here. And for that one, I've actually written my custom assembly that you can see here on the screen. And I've written an assembler in Python as well to turn this mnemonics into the machine codes that I've designed. And where I dropped at the place where I just was able to print the board to the screen and to initialize the board, which was real pain in this assembly, and print it to the board. And I just even though this assembly was inspired by 6502, it only had 41 instructions, which was miserable, just too few instructions to actually make a real game. Actually, no, it's not few enough, it's incomplete, and it would be kind enough to write the full-blown game of chess. But the problem was that I was limited to only 1K of memory in my device, and with such a poor instruction set, I would definitely just run out of memory. So when I realized that, the sprint board routine took around 20% of the memory I had, so I just realized that I won't fit the entire game into 1K, and I just dropped that. So instead, I decided to shift my goals a little bit, and again, like, just to keep things a little bit more interesting, and actually to make use of this kind of brand new Kim1 display, because this wasn't the case for Kim1s back in the day. So I decided to maybe just creating this custom chess game. So it's actually 1, 2, 3, 4, 5, 6, 7, 8. So this is gonna be the size of the board. And here on the right, I would be printing the score, and here the user would be capable of inputting the moves. So I'm not going to be implementing this sort of things now. So for now, I just want to implement the game itself and play it in the console, just to answer a very simple question: is it worth it, basically? Because if the gameplay is going to be fun, then definitely it's worth it, because again, it's the matter of hour, maybe a couple of hours writing this in Python absolutely from scratch. I didn't yet do that, so I would be doing absolutely from scratch, and that takes time. That might be a little bit tedious and boring, but in order to do the same in 6502 machine codes, it takes much longer. So before doing that, I really need to make sure that it's kind of worth that, and the idea is just to try this experience if we're going to be able to play the game. So without further ado, let's actually open the blank source file here and start writing our game. So this is going to be 2x8 mini chess by CodeMonkeyKeen for a custom Kim1 emulator. So this is what it's gonna be, right? Yeah, probably yeah, I just take time to create a sort of a border here. It probably doesn't make that much sense to you guys, but for me it's quite important. So because yeah, it just makes me calm before starting a new project, before writing something really. For code by CodeMonkeyKeen. Okay. Yeah, probably we just can, as far as this is just a prototype, I think we can keep it just like this, and this should be fairly enough. Okay, so the very first thing we need to think about is the board representation. So here we have the board. Let's make it like board representation. The very first thing to think of, and also the piece encoding as well. So yeah, and also the piece encoding. So piece encoding, right? So how the pieces are going to be represented on our chessboard, that's quite important. So here is a little fact from the 16 by 2 LCD display. So we have up to 8 characters to create user-defined graphics for them instead of them. So it's like if, let's say, like ASCII 61 equals to the character A, for instance, the LCD display does when it just boots, it doesn't know what the, it's not ASCII really, but let's say that ASCII character of 0 is equal to, and we don't know what it equals to. It's not a it's not this one. We just don't know what is that, and we can define this to look like a chess pawn, for instance, or another piece. And bear in mind the fact that we have up to 8 user-defined characters. It means that we can define 4 piece types for whites and 4 piece types for blacks. And that seems quite reasonable, right? So the pieces would be encoded like 0, 0, 1, 2, 3, 4. It would be white, sorry, 1, 2, 3. This would be white pieces, and then 4, 5, 6, 7. These are gonna be the black pieces. And yeah, so let's start. Yeah, we're gonna be defining them just right along the way. But before that, probably we can kickstart with the board representation. So the board itself. So yeah, I can't use 0 neither for off-board square nor for kind of like nor for empty square, because 0 is going to be represented the piece, and this is essential because if we don't use this one, we can say 8 here because it's not available on the LCD screen. So let's say that 8 is going to be empty square, and that's something we can already define so far. So for instance, we say 8 is an empty square, right? Then yes, for instance here 1 2 3 4 5 6 7 8, and it's probably copy and paste. So here we have 16 by 2 board, but in order to handle the off-board squares, what I really need to do as well is we need to have the sort of border, let's say, and I will use 9 just because it's the next digit after 8. So eventually the internal board would be represented like this. So the idea is that we can actually have so yeah, let's make it just like a little bit centralized, apparently, like so. Board representation is just, yeah, like this. Just want to keep things centralized to be visually pleasing, right? So yeah, here is the board, and we can say that 9 is going to be the off board. That's it. So now, okay, another thing. So yeah, I'm sorry, we actually don't need this to be 16 because the leftmost part is gonna get used for, yeah, for scoring and inputting the user mode. So you actually only need, yeah, 1 2 3 4 5 6 7 8. Yes, so we get rid of those. Yeah, I'm sorry guys. Yeah, just I don't know what to do this like full size. Actually, this is gonna be our chessboard. Okay, so this is gonna be our chessboard, and now it's time to start putting our pieces. So let's say here, well, I just duplicate this kind of thing down below to make it like use some sort of an ASCII characters to represent. So this is how the board printed into the console is going to look like. So just use this, make it. I'll map all these characters, so no worries. We'll just map those characters lay around. So yeah, so we're kind of doing two things. We're designing the game and thinking about the implementation meanwhile, and also when I'm designing this, I'm also thinking how would I be translating this to 6502 assembly language, because that matters as well. But in some cases, I would be going for simplifications because sometimes, well, for instance, I would be using Python. Well, no, I thought I would be using dictionaries. No, I'm not going to be using dictionaries. But anyway, yeah, so I would be sticking to those simplest possible programming techniques that would be easily reproducible in 6502 assembly. So no classes, no fancy classes, no object-oriented programming. So just trying to keep things like as simple as possible. I could have done this in C though, but in order to, if someone would ever want to follow this as a tutorial to create a game somewhat simpler than chess, then probably Python just easier to kickstart with. So I would be sticking to that. Okay, so let's say, yeah, it's not defining anything yet. So here on the left, we're gonna be having the king. Here, for instance, the queen, and here, for instance, the rook, and here the pawn. So I think these pieces are quite okay. And yeah, by the way, I forgot to mention that the pieces are going to be moving. So in order to advance the piece, it would be going like white are going right, and black would be going to the left. You know, assuming this sort of a setup, we can mirror the position. So let's, for instance, black king would be here, black queen here. Here we'll have the black pawn, and here we'll have the black rook. So in order to exchange in order to avoid instant exchange of the rooks, just to keep the game being a little bit more interesting. So I think that might be making some sort of a sense. All right. So I'm sorry. Now let's encode the pieces. So for instance, white king is gonna be equal to 0. So this is gonna be white king, right? Okay, and this is gonna be white queen. Okay, so let's say here we'll have the white king, white queen. So let's say 2 would be white rook. 2 is gonna be the white rook. White rook. 3 is gonna be the white pawn. So in regards to how the pieces are gonna be moving, I have some considerations here as well. So I think that pawn is gonna be moving just like in chess. I'm not sure about the pawn promotion though. It's a little bit tricky question. So I didn't yet take the decision on that, to be honest. It might not be the best ever thing, but maybe the pawn would be promoted to rook. That would be a killer thing. But maybe I can do this like just, I want to simplify the rules, so I don't need to implement much in 6502 assembly. So I'm not sure. Let's not think about this for now. Yeah, let's not think about this. But anyway, the queen is not going to be moving like queen in chess. It would be moving just one square, like in any direction. And this reminds me like the old the games that were before chess, and also in say Chinese or Korean chess, the queens. There was no such a thing as a queen. They were just advisors that kind of move in all the okay, just forget that. So the if queen is going to be moving in all directions, it's kind of a little bit an overkill. So I think that just having the rooks that would be shooting on this lines is just fairly enough, and the rest of pieces would be moving just one piece ahead, one square ahead. So the king is going to be like probably like a queen moving to all the directions. Pawn would be moving just like the chess pawn. No double pawn push, yeah. And what else? And the rook would be moving, yeah, just like the rook. So only the queen is limited to one square. I think that just be okay. And anyway, if you don't like this, the rules that I'm going to be defining here, you are absolutely free to define your own rules, and it would be really trivial to implement those changes. So now let's say, so if I want the opposite position, so let's say 5 here, so 5 and 6. So this is gonna be white, the black king. No, sorry, not 5. It's gonna be 4 and 5. So 4 is gonna be a black king. And 5 is gonna be the black queen, right? So now 6, so how I did this, 0 1 2 3, right? 0 0 1 2 3 4 5. So this here, let's say 6 7. So rook is gonna be 6, black rook, and here black pawn. And I think we are done. We're done with this piece encoding. So yeah, probably we could have just slightly separate like this. Okay, so far so good. So did I miss anything? Yeah, probably not. Yeah, so Now actually what we need to do, so just grab this, and yeah, also we need to define the sides to move, but yeah, let's probably do that. So let's define the white, it's going to be equal to 0, and black, so it's here, just the sides to move. Black is going to be equal to 1, and side, let's say just better colors. And here, side to move. So side is going to be equal to, well, I think that it's not essential to stick to white to move first, because I think that black moving first might also be on the cards. Maybe not. I don't know. I didn't yet take the decision on that point. But anyway, so in the next thing to define is the board. So board is going to be just an array, and here I want to initialize this just right out of the box. And I would be doing the same in 6502 assembly as well, by the way. So, because it's just easier to pre-initialize the memory without spending bytes for those initialization routines. I'm going to be doing this at 0 pages, definitely. Okay. Right. So, oh, sorry. Yeah, so here is the board, and well, I think that now we want to print board routine to provide this one. So let's say def print board, and here I want to loop over board rows. Well, yeah, it just takes too long if I just want to be typing all the commentary. So let's just, I want to be talking through this because I don't really want this video to take forever, right? So let's say first we want to loop over the board rows. So for row, the code is going to be self-explanatory in range of, so we get 4 rows, right? And then for column in range of 10, because 8 and plus this edges, like, so it's going to be 10 elements, so 4 by, so this I need to mention, so this is going to be 4, it's better to say 8 by 4, 8 by 4 array. Okay, let's call it, it's actually called mailbox. So this board representation is called mailbox in chess programming, right? So yeah, and now we need to calculate the square. So to convert this two-dimensional coordinates to the square, and we need to say row multiplied by the width of the board, which is 10, plus the column. And now we can simply print. So for instance, I want to print this space and then board array indexed by the square, right? And I want to wait, so yeah, at the end I don't want to print the new line, and here every row I want to print the new line like so. So that should make sense. Okay, yeah, that should be making sense. We could have also print the rows. Well, we'll see. Just, yeah. Well, anyway, let's try to call it. So print board, and so I'm opening the terminal of the current working directory, and by typing Python 3 2x8 chess. So maybe I should call it 8x2. Yeah, maybe I should call it 8x2 for name. 8x2 chess. Yes, probably first we should treat the columns and then the rows. Might be wrong, but 8x2 chess.py. Okay, so must be string, not the integer. Yeah, and that's because, well, for now I can just stringify it, but anyway, I'm gonna be using some mappings in the next run. But so anyway, we just printed our board, which looks like exactly as we wanted it to look like. So now we have our ASCII pieces. So let's call it pieces. This is gonna be a string. And now, so first we need to map the ASCII characters to this guys. So first it goes the index of 0 is white king, then white queen, okay, then white rook, white pawn, and then black king, black queen, black rook, and black pawn. And what we can do now, we can just say pieces indexed by what? Pieces. Oh yes, out of range, because we also have this empty square and off-board square. So this is going to be empty square. This is going to be the off-board, right? And here is the board. So just like what we have printed, like provided here. So let's check this out. So queen, king, rook, pawn, queen, king, king, queen, king, queen, rook, pawn, king, queen, rook, pawn. Okay, so far so good. Well, probably we don't really want to print this off-board squares, so we can avoid doing that. So I can say if, so actually we can define the piece here as well. So this piece is going to be equal to whatever we have the board indexed by the square. And here we can just say piece, and here we can say if piece is not equal to 9, which stands for off-board. So in this case, we can just print our board. That's pretty much all about it. Now about the ranks, well, we could have also print the ranks here, but as far as I don't really know how exactly the user input on my King1 emulator is going to look like. I don't really want to spend time on providing the coordinates like I1, 2, A, B, C, D, E, F, G, because probably there would be a different encoding, somewhat similar to what it was in MicroChess by Peter Jennings back in the day, 1979, if I'm not mistaken. So yeah, I think that we can keep it like so for now. And well, actually, I don't know if we actually do we want to print? Yeah, let's just stick to this representation. I think that should be fairly enough. Okay, so the next thing we want to do is to generate moves. So define the function generate moves. Right, and here first thing we need to do is to loop over the board squares. So for square in range the length of the board, right? And we can just print. So yeah, we want to define the piece. Pieces would be equal to whatever we have on the board indexed by the square. So let's print the piece, but let's actually print it in the ASCII code for a piece. And we want to generate moves. So we got all the pieces, but we want to only pick up those. We don't want the off-board squares. We don't want empty squares. We only want to have the pieces that belong to the side to move. That's pretty much all about it. So in this case, I'm just thinking, yeah, so we need an additional data structure. So let's call it piece to color mapping. So let's call it colors. And so for this, guys, we have index of a white king is going to be 0, which is actually white. So I can use white here, white, 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 white. And then we have black, 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 black. And for this, guys, we don't want anything, so we can say either -1 probably, just or we can say like no color here, no color equals to -1, for instance, or maybe, well, -1 is fine. Okay, this should be fine. So here we have no color, and here we have no color as well. So yeah, and now we want to say if colors, indexed by the piece is actually equal to the side to move, right? So either white or black. In this case, we want to print. Our pieces. So let's have a look. So now we'll print the white pieces, and if we change the side to move to say black, all right, then we only would be generating moves for black pieces. But I want to do this slightly little bit different way. So if if colors, if indexed by the piece is not equal to side, I just want to continue just to save another indentation here. So now we can do it like this. Same result, but I just like how this works, how this looks a little bit better. So we just drop back to the white. Then we have all the whites. So we're picking up all the white pieces, right? And actually, that's fairly enough to start generating the moves, right? Okay, so far so good. Now the interesting thing is gonna start basically. So the next thing we're gonna do is to loop over the directions of where the pieces are about to be going. So loop over offsets, and for that purpose, we need to create the data structure for those offsets. So let's say we can call it move offsets, and literally the rules of the game, so like where the pieces are gonna be going to. So let's call it offsets, and I'm gonna be using array of arrays here. And again, like, so here for instance we'll have white, we will have white king and white queen. So I'm keeping this order. So this order is kept for all the data structures. So white king, white queen, white rook, and white pawn. And here we'll have black. So black king, black queen, black rook, and black pawn. So you see, like, the index, so this is this index of 0, 1, 2, 3, 4, etc. So for white, so these are gonna be empty for now, so I'm gonna be adding them one by one because I didn't yet debug this. So how the king is gonna be moving is gonna be moving one step to the right, one step up, one step down, one step left, and diagonally. So that's how the king moves are gonna be working. So probably we could have started by actually the king, well, no, I think that just might be fine. It would be jumping off board just for start. But anyway, so one is like one step ahead, -1 is one step backwards. So let's say king here. So this is +1, this is -1, this is -10, and this is +10, and this is +11, this is +9. This is minus, oh my god, 9 or -11, I'm not sure. Anyway, so 10, -10, 11, -11, 9, and -9. So this should be the case for white king. So I can simply say for offset in offsets indexed by the piece. Here, what I want to print the piece, and the offset. So let's have a look if it kind of works. Okay, so again is going like this. So far so good. And yeah, actually now, yeah, we also need to define the captured piece, because otherwise we won't be able to restore the position. Okay guys, to be honest, it's shame on me, but I don't really remember this by heart, so I will kind of look up some of the sources that I've provided before, and in particular I'm going to be using my toy fish for this sort of a thing, because I don't exactly remember the order of how this is done. So source and toy fish pie, yeah. So okay, so defining the piece, it defines the side to move or offset. So we first need to define the, okay, so we'll yeah, obviously we'll have the initial, I wanted to get rid of this loop. So this loop is a loop over the piece, over the attack ray for each direction, and we only need this for rook. So it's very tempted to not allow the rook moving like that, but yeah, let's go a bit harder way, because we've simplified a lot already. So yeah, first we need to define the target square, and then this loop, and yeah, and here we go for a captured piece. So yeah guys, I'm sorry, I just go for a little bit of a cheating just to save you time watching me debugging this from scratch. So again, like this target square goes, yeah, just right after this offset. Yeah, so we do define our target square. I don't want this for now. Yes, probably just get rid of it. And here, so this loop is the loop over the attack rays, or over the squares along the attack ray. So target piece plus equals offset, and keep captured piece whatever we have the board indexed by the target square. Yeah, probably. Okay, I just go extra mile and add some commentary. So yeah, loop, or at least the most essential loop over the board squares. Here we want initialize a piece. Here generate moves only for those pieces. Only for those pieces that belong to the side to move, right? It's a bit, so let's say, if piece doesn't belong to the line, to the side to move, let's say skip the piece. Skip the piece that doesn't belong to the side to move. Yeah, now it sounds much better. So here we have a loop over move offsets over directions, or move direction offsets, like that. Okay, so target square is self-explanatory. So the next square where we're supposed to be putting our piece, and this loop is also essential. So loop over the attack ray within a given offset, within a given direction offset. So yeah, now this makes sense. Loop over the attack ray within a given direction offset. Okay. Captured piece is whatever, yes, just literal captured piece, so self-explanatory. So every time we're going to be adding the offset to the target square, so source like being equal to source square, then we would be adding the target square. So for instance, if we have this king moving to the right, it would be +1, so king moving here, etc. So yeah, that's the way to go. And a little bit more cheating, guys, just to just to end up this generate move function quickly, because we have lots of things to do a part of that. And yeah, probably could also grab this, maybe, okay, maybe write it from scratch. So okay, so yeah, just better captured piece is okay. So here I just return. I was returning the move list. Yeah, I was. Okay, so this might be done a little bit later. So for now, I just want to. Yeah. Okay, and yeah, that's pretty much all about it. So yeah, now let's visualize. Now let's kind of visualize making moves and then making them. So make move and take back. So board target square is going to be equal to piece, and board square, source square, is going to be equal to 0, which is no, sorry, to 8, because this is empty square. So probably we could have, well, no, let's just know that 8 is kind of empty square. We could have defined that as well, but yeah, so 8 is the empty square, that's the reason. Okay, so board square is equal to 8. And we also want to change the side to move, so I'm just XORing with 1. So 1 would become 0, 0 would become 1. And take back, so board target square should take the value of the captured piece to restore the piece there, right? And board source square, just square is gonna be equal to the piece that we had. So I just quickly verify. So make move target equals to piece, right? And this empty, and when we take back, oh, this is the code for promotion. We potentially might be adding that as well later on. So here, captured, and source is piece. Target is captures. This one is piece. And I want to print board here. And, oh, sorry, what have I done? Print board here, and just wait for user input just to see the output. Just break into program at some point, and here as well. And here we go. Oh man, reference before assignment. You must be kidding me. What do you mean reference before assignment? Set is equal to white. Line 122. Oh, where are my line numbers? Yeah, I was recording some video that didn't welcome the line numbers. 122. Oh, okay, and generate moves. Hold on, guys. I feel really confused about it. So, oh, colors piece is not equal to site. Hey, this did work. Why did this code actually results in error? It's really strange. Hold on, guys. I just need to figure out what's wrong. Okay, guys, it's a little bit of a mystery for me, but I have no idea why this is needed actually. But for some reason, we need to define the site to be global here, just to give the generate moves an idea about it. I don't know really why is that happening like that. So that's complete mystery. But anyway. And also, yeah, here is, let's just, yeah, probably get rid of this condition. So just to show the initial experience, So we're moving the key along the direction, and yeah, it's like it's just going forever literally, which is wrong. It should be dropped. So every time we hit the offboard square, it should actually drop. And just want to make sure where is the, yeah, so it should be done. Yeah, it should be done first before anything else. So I can say if so did I use captured piece? Yeah, actually captured piece. Okay, so if captured piece is equal to 9. So what is 9? 9 is like this offboard square. So this is general rule for all the slider pieces. Well, actually we only have the slider and rook, and this won't ever happen for king, but as far as we don't have the offsets for other pieces, and I'm using the king just to debug things. So yeah, in this case, I just want to break, right? So now, if I run this again, so king is moving until it goes here, and then it drops. Nope. Yeah. Okay. And it couldn't actually move like upwards and downwards as well, because yeah. So we just put. So just probably to give you an idea. So here, let's put our king here. Okay, so one direction, another direction goes up, going left, right, and that's it. And now, so these directions are working nicely so far. And also let's put the king here. And these downward directions are working nicely as well. So it seems like the king is working quite okay. Now the next thing, we actually need to prevent all the pieces but the rook from doing this sliding. So here down below, so let's say prevent all pieces but a rook from sliding. So if piece is not equal to, and now we need the code for a rook. Well, actually we can use in here. So what's the codes for rooks? 2 and black rook as well. 6, right? 6. Yeah, 2, 6. If piece not in 2 or 6, then I just want to break. So now the king. Okay, just hold on a sec. I'm wondering. So initially king is here. Oh, it just made a move, I believe. Yeah, it just made a move. Here, 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 here. Yeah. Now this is okay. All right. Okay. Another thing to consider. It shouldn't be able to capture the own pieces. So let's, for instance, so here 8, here we have, let's say 2, and here let's put some black piece instead. So another test. So now you see like it captures own piece, captures opponent piece is okay, but it shouldn't be capturing own piece. So to provide capturing own pieces, this is it. Yeah. So we need to verify. So where did I put? So the order matters. So I'm referencing my previous codes here. Okay. So here, prevent from going off board. Here, do not capture own pieces. So if, and I'm using this colors array again. So if colors indexed by the captured piece captured piece. So whatever we captured, if it is equal to the side to move, then we want to break, because we don't really want to capture own pieces. So now it shouldn't capture, yeah, and it doesn't capture own rook anymore, which is good. So far so good. And yeah, it doesn't slide anymore, which is good as well. So we're almost there, sort of a thing. Okay. So the next couple of rules for pawns, yeah, we'll do them as well. But before that, I'm just thinking. Before that, yeah, let's restore the position. Let's actually restore the position. So it was 0, it was 2, 8, 8, like this. Yeah, now it just, yeah, probably just breaks instantly, because king in the initial position, the king is not going to, so let's just print the board. Because in the initial position, king is not going anywhere, hence just breaks straight ahead, which is the case. Okay, so now let's actually add the rules for pawns. So let's and okay, yeah, hold on a sec. Yeah, also this should be done for black king as well. I don't know, I'm going for a bit of a duplications. It's not the best ever way of doing things, but I think I can optimize this when it comes to 652 assembly. So let's try the black side is equal to black, and the king, let's put a king somewhere here. Let's say okay, captures, okay, one more time. It goes right, up, captures here. Why doesn't go left? Hold on a sec. I feel a little bit confused about this, guys, just sorry. Just want to make sure if the king, oh, what the heck is that? Okay, something has gone horribly wrong. Oh, why did I put, no, it should be, oh my god. Okay, and if I now put him here, I can't get why it doesn't capture. Should it be able to capture this pawn, but it doesn't for some reason. And it, on the other hand, it captures his own piece. Yeah, this is going wild a little bit. I feel completely confused. So what did I do wrong here? Is this side actually? Okay, guys, just hold on a sec. Okay, guys, I just probably got an idea. So this should be happening because I just forgetting to change the side to move, right? Yeah, so I'm just changing the side to move here, but I forgot to change the side to move once I'm taking the move back. So I was playing around with the white king again. So yeah, let's see. Oh, it's just black to move currently already. Yeah. Okay. Yeah. Let's try to test this one more time, because yeah, just so here, and not go into own site, and same should be here. All right, and here. Okay, and here. Okay, so it now takes all of those. Right, and now let's make it 4. Let's make it 0, and so now same task but for a black king. Not touching on pieces here, right? Not touching. Yeah, just forgot to change the site while taking the move back. Okay, one more time. Yeah, so far so good. And here it should be grabbing the opponent's pieces. One more time. Yeah, it grabs, and here it grabs as well. Yeah, okay, now I like it. So now it works like it should be, basically. Okay, so from now on we can actually just add all the possible directions for, well, actually for queens, for instance. So for queens, for both black and white queens, we have absolutely the same move offsets, and yeah, it's really going inefficient in terms of I'm just duplicating the data all of the time, but this simplifies the code quite much here. So yeah, I just can do this in one line. Okay, so probably I just keep sticking to this. Now the rooks is going to be the same part of this part, so just going like orthogonally, and here it also goes only orthogonally. And I don't know, guys, now I'm really getting tempted to actually use the bishop instead of a pawn, because queen in here doesn't make that much sense. I don't know, maybe we could just, because I don't really want to go for this complications with not moving if the piece is blocking, only capturing diagonally, and literally, yeah, I think, I don't know, probably, yeah, let's just try to make this, so king, queen, rook. Let's make it a bishop, because yeah, I've been doing this with pawns enormous number of time on this channel so far already. So let's maybe just try to make it a bishop. Yeah, I think that might be just fun. So here would be white bishop. Here would be the black bishop. Yeah, and exchanging rook for a bishop is also a disaster, but yeah, because in this case I can just do the following thing. I can just do like this, and so I was dreaming about the game of chess that kind of like easy to implement. Like doesn't have this special cases ever. So black bishop. Yeah, you might be treating this as just to be a cheating, but again, like I'm developing this game from scratch, so I'm absolutely free to do whatever I want here. Yeah, so if you want a real full-blown chess, check out my 95 video tutorials, 95 videos series on coding a bitboard chess engine in C, and there you would have pawns. So yeah, okay. I can now change this pawn to a bishop, and this pawn to a bishop like this. Do I have the word pawn anywhere else? Nope. Okay. So yeah, okay, now it generates the moves. Okay, now the problem is it jumps over the pieces. Yeah, so here is another disaster that we kind of jump over the pieces. So yeah, I need to fix that as well. So the captured here. Okay, so to prevent this, say stop iterating if captured opponent's piece, and if it's equal to side bitwise or 1, which means the opponent's piece. So now we capturing the bishop and no longer and not going anywhere else, which is exactly the case. Okay, so thanks. Yeah, that was, oh man, that was nice. All right, so okay, yeah, it would be really more kind of tactical game without pawns. I don't know. I really want to try to play this. If I don't like this, I can add pawns later. It's not a big deal. And again, like yeah, when I'm gonna one of the most interesting things is that when I'm gonna be implementing this in the assembly language, I will probably just once define these values, and then I would be just probably make a lookup table of pointers to just jump to point to the different places of in the memory. I don't need this. I don't need to do this now, but yeah, then it would be really on the cards. So just for every piece, just I would have a pointer or word to jump in this table. That kind of makes sense. That's something that was done in Micromax by Hartmut Miller at some point. So yeah, now we should already have the moves for all the pieces. Okay, yeah, so far so good. Okay, so the most essential part, actually generating the moves, now in theory should be working properly. Just to make sure that it kind of works properly, we just say like this. I just want to see how the king and queen are moving, yeah, as expected. So yes, okay, yeah, okay, that's great. So now let's separate the make, move, and to take back functions the following way. So so just take this away from here. So we're not going to be doing this within the generate moves. So make, move, on board, let's clear that on board. Where else to make a move? Okay, so def make move. Right, not the male move. Make move, and the take back, def take back. In the ear, this one. All right. So here you want to make move. Okay, and here I want to take back. Just to make sure that we have exactly the same output. Yeah, just hold on a sec. I probably, yeah, I'm gonna be passing the move to the make move. Yeah, so now it's time to make a move list here. So move list is gonna be a list of moves that we're gonna be populating. Well, Python allows doing this dynamically. I'm not gonna be doing this, like, I'm not even going to separate the logic of making and making moves. I would be doing everything in the one single kind of function here. Just for clarity, I'm separating these things, but in 6.502 assembly, I'm going to be doing the only search routine that would be doing all this stuff embedded. All right, so, well, actually, yeah, it's just me just reference. So where do I append the move? Yeah, and another important thing, so if we're capturing the key that we want to return, the empty list, which would indicate that the line is kind of sort of illegal. Okay, so if captured piece in either white king or black king, which is 0 and 0, 0 and 4. Okay. In 0 or 4, then return. Here I want to append the move list. Yeah, move list. Yes, append source, target, piece, and the captured. So square, target, square, piece, and the captured piece. Yeah, this should be working. So king capture is, let's say, drops the search. Okay. Drops the current branch. Okay, in a search. Okay, and here I just want to populate move list. Okay, and yeah, now just another little bit of a cheating. I just use this. Just redefine this make move and take back slide a little bit like this. Sorry. Just to reference this. Well, actually, okay, okay, no more cheating. So I would. What am I? Self and the move. Yeah, I'm passing the move. Yeah, so let's pass the move, and so board target score is gonna be equal to move piece. Board. So let's make it source. Yeah, let's make it source and target. That's just nice. So board move target move source. All right. Move target move captured move piece and move square source. Yeah, should be the case. Okay, and eventually want to return the move list from here. So just looking for a proper indentation. So returns move list, return move list. Okay, so far so good. Now what I can do now, I can now actually create a move list like this. Is equal to generate moves, and let's print the move list. Yeah, so here we go. We got the moves. We got the moves that has been generated here, and now, well, it's already, well, it's probably already time to draft the search function. So search best move, search for best move. Let's say def search So we need to loop over moves in a move list. So that's the first, the most essential thing. So for move in, well, actually I can, so move list, so generate moves, move list is equal to generate moves, and for move in move list, all right, we can make move and pass in the move, and want to print the board and wait for user input just to pause it a little bit, and then I want to take the move back, take back, and the move, and then the print board. So this should result in exactly the same output we have before, but a little bit like more organized code, I would say. So here, just want to search, and list object is not callable. Am I trying to call the move list somewhere? 152. Oh, sorry. Yeah, definitely not callable. You must be kidding, man. Why this goes wild with a site? I don't know. It's complete mystery to me, to be honest. You must be kidding. Oh, you make move as well. Yeah, it seems like I completely forgot how Python works. Okay, I just don't really want to be okay guys, sorry, I need to go to Stack Overflow for a while. Okay, so it seems like every time I want to modify the global variable, yeah, so that's the case. As far as I've been actually using the class here, so I didn't face this issue before, but here, yeah, it seems like I'm forced to use this global variable because I do modify this global variable to make sure that I'm I'm responsible for this possibly occurring bugs here. Okay. Sorry guys, just the sunlight is now makes me blind. It just shines to the screen. I need to deal with that as well. Just hold on a sec. All right, now it's a little bit better. So where did we stop? Yeah, so I need to say this global side everywhere. It's really don't like how it looks, but yeah, this is Python, baby. That's what I can say. Okay, what? Take back, take 0, 1 was given. Actually, it should be taken the move as well. Yeah, now finally, yeah, we have exactly the same output. Okay. So the search algorithm I'm going to be using here is the Ningamax brute force search, and on the classical chess, it's got a bit of an overkill because too many nodes has been searched. But here, as far as the board is reasonably small, this might be just kind of fine. Another little problem. So here is the here is the entire algorithm, by the way. So a bit of a problem here is that if I'm going deep, well, I'm not sure how deep would I be able to go on my emulator. Well, definitely deeper than with a normal chess, which probably might make the game actually really interesting. But in that case, I'll need to introduce the search ply in order to make sure that it would always be picking up the shortest distance to the mate, which I didn't implement in my stockfish just for simplicity, and sorry, in my stockfish, in my toy fish, for simplicity, because here it only reaches the depth of 3 and then drops. So here would it be plus ply, or yeah, I meant to say like minus ply. Okay, guys, I'm just want to quickly check one little thing. once I've written a chess engine called MicroChess, and initially it has that, I don't know if I can call it a bug. If I can call it a bug, so it didn't consider the closest possible. Yeah. So just returns 10,000. Okay, and in this case, yeah, it would be a bit of a overkill to do this in 6502. On the other hand, okay, what engine to take? Okay, let's go for my baby C then. Here, this is my bitboard chess engine I've been talking about, by the way. So search. Okay, just better say it's probably minus ply. Nope, plus ply. Oh, that's because I'm returning the minus main value here. And in toy fish, do I return the minus? Oh yeah, here it is. Oh no, just the best score at start. Okay, ignore it for now. So yeah, if I can always add this later on, basically. So yeah. Okay, so for now, just forget about the ply detection. So instead, just gonna grab this. Yeah, I just gonna grab this entire search routine here, and see what do I need to add from this. So yeah, definitely. So this line. So this function is going to get called recursively, which is important. So what does it take? Only depth, right? Yes, only the depth. This is the search depth, by the way. So here we'll have recursive nigamax call, and I guess I call it score. Yes, score equals to minus search depth minus 1. All right. So yeah, we need the best score. So yeah, here, by the way, we have the escape condition. We want to evaluate leaf nodes in a search. We don't yet have the evaluate, so let's just return 0 for now. I just want to run it just to show you how the moves would be generated recursively. It wouldn't be considering any move, but it would be just reversing all of the moves, which is exactly what I want to have now. Yes, this best source and the best target squares are temporary ones. Yeah, and then I need to have a couple of global. So let's call them current best and current best. Well, or okay, can make this as well. So here we have the temporary best move, or let's say best move so far, best move so far. And here we have the best score so far. All right. So what else? Yeah, I would also need the global best move, and yeah, where to put them? Best move in the position. So here, best from, best source. I don't even remember how did I initialize them. I probably didn't even initialize them at all. So let's make them like -1 as well. Okay, but the problem is that, yeah, if they have the same, they shouldn't have the same best source, best target. So let's call this let's call it current best, and here also use the global best source and the global best target. Okay, so move list. So yes. Now here, this condition, move list. So here the king has been captured, right? In this case, return 1000. So we're not taking apply into account. So one date would be like this or something, but we don't care about apply for now. So with the depth no more than 3 plies, this should be just fine. Okay, and this should be still playing quite a reasonable game. Yeah, just trying to keep things simple. Yeah, so this already should be kind of detecting the checkmates at some point. So would it be possible to checkmate, to find a checkmate with even without the evaluation, I believe. So now this move list, yeah, make move, this recursive call, then the brute force search algorithm itself, and yeah, so we're almost done. Okay, so now this is the heart of the Nigamax brute force search. So this is the Nigamax brute force search algorithm. So if we found if we found a better move, what we do, we just update the best score and update the current best source and the current best target to those that are available in the move, right? And then this should be here. Then before return from, so here, want to return the best move, the best score. Return the score of the best move, and here we want to associate best move with a best score, which is essential as well. So yeah, this is pretty much all about the Nigamax brute force search algorithm. So well, in theory this should be kind of working. So let's try to search for depth 2 and see how it goes. Okay, so I made a move with the white, and now all the responses with the black pieces. Okay, name self is not defined, so yeah, sorry, best like this. So one more time. So all the responses for this sort of a move, right? Then for this move, for this move, for this move, okay, yeah. So it seems like it's generating moves perfectly well. Let's try depth 3. So it just makes move for white, makes move for black, and then all the moves available for whites. Okay. Yeah, so it seems like, well, at a glance, at least at a glance, it seems like it's working. So you know, I can be pretty happy with that. Okay, guys. So now a few more things left. So we just need to quickly draft the evaluation and just probably grab it from here. So we need the weights. Yeah, I just grab the. It would be altering along the way and commenting out, and commanding just to make sure everything kind of works properly. So by default the score. So this is the static evaluation score. So here, want to loop over the board squares, right? So land on the board in this case. Okay, piece, so we need the piece, yeah, pick up the piece. So if piece not in, it's not empty or not off board, and I want to comment this out for a while, and we're gonna be just testing this eval separately for now. So evaluate current position. So it doesn't take any arguments at all. So just sprint pieces to piece. I just want to make sure it does grab all the pieces it has. So it returns the negative score for black and the positive score for whites. Oh, it's clear. Actually can explicitly mention that. So returns negative score for blacks and positive for white pieces. Right. So we also need the global. Do we need the global side here? Maybe we don't. Maybe we do. Okay, we don't need, yeah, as far as we don't change the side here, it's no need to, yeah, we're gonna just reference it globally. That's okay. So here are all the pieces that are being evaluated. So it goes like this. So white king, white rook, black bishop, black queen. Then so it just goes like this and like this. It traverses all the board array and picks up all the pieces, which is okay. So now I want to print the weights for pieces. So weights indexed by the piece. And now let's provide the weights. So this is the material score weights. Okay, and weights is going to be equal. Now I need to evaluate the pieces. I don't remember. Well, the relative score is obviously like in chess, like pawn is equal, like knight is equal 3 pawns, bishop as well. Let me just reference quickly my my weights array here. Okay. Okay, so yeah, I've used 10 thousandths for a king, which I don't have that big numbers in, actually. Yeah, these big numbers for a big computer is going to be a bit of an overkill, so I need to think. So maybe I would be using just the relative. So if I can just use... I just want to make them sort of a small. So maybe, well, okay. We just, yeah, just it would be with the different values. It would be playing a little bit different. But I think that just to get an idea of general kind of how the game would feel to play, these values should be just fine. Okay, so 10,000 for this guy. So for queen we take 900s. For rook we take 500s. For a bishop we take 300s, like this. And the same values, but the minus here, here, and the placeholders for off-board score and the empty score, which are not going to be used, but just to avoid the errors. So these are just the placeholders. Okay, so now we got our weights, and now we can already see the values, and here the score should be, so just print in this evaluate, and just want to print the score. So score is going to be, should be 0. Where is the self? Nope, not the self weights, just the weights. And we got the score of 0 because there is the even number of pieces. So let's say if I now get rid of, say, 1 king, it should be minus 10,000. Yes, which is true. Here it should be plus 10,000, which is true. Okay. 4. Yes. And for instance, so what's the piece? Rook. So now this should be plus 500s. Okay. And here it should be minus 300s because of the bishop. No, minus 500s. Is that? Oh yes, it's rook. It's rook. Sorry. So it's 500. So here minus 300s, which is the case. Okay, so far so good. And now we need to, just to give the pieces an idea where to develop. But on the other hand, you know, like on the for real chess, we really need to provide these p-square tables to give them an idea where to develop their pieces. But I'm just wondering, it's not that many moves here to consider. Not that many moves, so probably we can ignore that completely. I'm just really wondering how he's gonna be playing if he just completely ignores the positional scores. That's gonna be interesting then to consider. Okay, so search and yeah, I'm just wondering. Here return self-evaluate. So now it should already be actually printing this best move. And just print best source and best target. So, oh my god, -1. Something's horribly wrong here. Oh, just need to search, obviously. Okay. No more holds. No more holds. Well, it's clear that it's the recursive nigmax call anyway. Okay. Name self is not defined. Self-evaluate, yeah, definitely. Oh, maximum recursion depth. So I'm somewhere, I'm not returning. Oh, because I need to return that. Okay, I don't want to print the scores. Yeah, but for some reason, oh, that's because it should be current, and it should be current here as well. Okay, so now we got some from square into square, so I have no idea what this means. So in order to get done with that, we need to map another, so this like array, and I grab currently this one. So here, so yeah, board coordinates, so coordinates equal to something like this. A1 to H1, yes, makes sense. So copy. I'm not going to be using this in my 6502 version, I'm sorry. Definitely not. I'm going to be just mapping like in MicroChess by Peter Jennings. I really love the idea there. It really makes sense. Because we're going to be inputting the moves. They are like via the integers, not this, not the coordinate notation. But in this version, coordinate notation is just okay. Coordinates, and actually coordinates best source, and I can actually say plus here, string concatenation. B2 to C2, so A, B, C, D, E, F, G, H. Yeah, okay, I realized that now it's really time to print the coordinates. So go back to the print board routine. It's not seen that nicely. So print A, B, C, D, E, F, G, H. Okay, it's a bit missed. Okay, and let's say the new line after. Okay, and also the row. So if call is equal to 0, I want to print the row. What? Okay. No, hold on a sec. And like this. Okay, 0, 1, 2, so this should be 4 minus row, and plus 1, so maybe we can say 5 minus row, or 3. Math is not my best thing ever. Okay, and row in 0, in 1, 2. Okay, now it looks much better. So I can probably so let's say if row is not equal to 3. Okay, and Yeah, this looks like much better. Okay, so b2 to c2, so we have b2 goes to c2, so moving rook one step forward. Well, it kind of picks this move because it kind of like it's the first move to consider, and yeah, that's the reason why it takes it. So yeah, we just need to have a look how the self play would look like to make sure to answer the question whether not having this b square table to motivate pieces moving somewhere else makes sense or not. But anyway, so in order to do that, yeah, we now, so the very last but not least thing is left here is to implement the logic of allowing the user to enter the moves and computer to respond back. All right, so yeah, another bit of a cheating, so just to save you time, guys, I just grab this loop for user interaction. So this play, yeah, I don't really remember what exactly I did there, but yeah, this should be just kind of fine. Okay, so let's have a look. So yeah, I guess this was the print board. So this is, oh, actually I don't need this. I don't need this really. So so this is the main, sort of a main part. Okay, so just static position evaluation, right? What am I doing here? So this is the game loop. Okay, let's make it like def play. Just want to organize code a little bit. So so main loop. Okay, let's just give it main. Okay, so your move. Okay, so it takes just the user move. So user source. Yes, actually like this. So here I'm. Okay, let's just go command and things. So user prompt. Okay. Skip less than 4 characters. Skip if less than 4 characters. So here, 1 to parse user move. Here, want to make the move. You want to print the board. So here, make user move. So yeah, just from this index, from this coordinates, we're going to be getting the index of whatever. So the idea of this line, just to give an idea. So one to convert user like b2 to the source square, and then the another coordinate to so we need the index of this whatever coordinate we have here. So just because a computer kind of thinks from the perspective of this source and target scores of where the board indexed by the source square and goes to board indexed by the target square. So we need to convert this user-defined coordinates to from and to square, and the reason and how we can do that, we can do it like this. So here I just say print user source and the user target. Yep. So I just I can even get rid of the rest for now. So let's just play. So play, yes, play the game. Okay, so for instance, I want to go like B2 to B2, no, to D2, for instance, to D2, and enter. So it translates the B2 to 12 and D2 to 14. So that's the idea. So far, so good. So I can get away from here. And now, what we're gonna be doing next? So making the move, right? So printing the board. So not doing anything else for now. So let's try this like B2 to D2. Oops. Self. User. Yep. So we just manually setting up. We're manually creating the move element here. So source square and target square, user source, user target, and the piece and the captured. So captured whatever board user target, piece is whatever board user source. Okay. So again, B2 to D2, and we just moved the piece, and now we can move another piece. So for instance, like G1 to D1, for instance. So G1 to D1. Okay, now we can capture, for instance, so D2 to D1. So yeah, this is how the game is intended to be, basically. Okay, now here, make computer search the best move, search for the best move. So depth 3, so this should be fairly enough for now, even though we don't have a question search, so might be some piece giveaway at some point, but I just really want a proof of concept. I just want to feel how the game sort of kind of feels. So again, the print board again. And yeah, we just can Control X, we can just put it here and here, right? Okay. So here, make moves, just get rid of the selves. So after we fire this search, we have the score. Obviously, we can print the score. We can actually, well, we don't even need that score because we just search. So it's literally enough to have the best. Well, on the other hand, we just can have that as well. The print board, print score. Doesn't make much sense. It's probably just the material score. Yeah, so it would be just the bare material score because we don't count the positional score at all there. I'm not sure how the layout would look like after. It should be just fine. And after we've searched for the best move, this global best source and best target already being associated with the best score that was found during the search, and we just force it to make a move using this best source and best target squares as the arguments. And finally, so if either of sides gets mated, just end the game. End the game, yep. End the game if either of sides gets mated. And brings the checkmate. That's pretty much all about it. Okay guys, so now should be possible to play the game, believe it or not. So I don't even know where to move, but bishop, well, it doesn't have the move legality checking, so you literally may move anywhere, which I don't know, maybe I disallow this in the 6.5.2 version, maybe not, I'm not sure. But anyway, I want to go with the bishop from b1 to c2, for instance. So b1 goes to c2, and I get the score, and oh my god, the rook has just captured the queen. Oh, and that's logical. Yeah, that's because the queen kind of considers to be a more valuable piece. Actually, it's not in this game because queen has way less possibilities here. So yeah, but anyway, this means that the material evaluation kind of makes sense. So a2 goes to a1, and we capture back, and he just moves his bishop, which is the first move to take there. So yeah, this might be interesting. Yeah, I think I should actually add some. Yeah, I really want to try to add some. I want to add some positional scores, and yeah, before that, just want to see how the computer is going to be playing versus itself. So now it should be playing versus itself. Nope, don't. So just don't do all of this. Then nope, just yeah, skip this one. So I could just. So you see, like, yeah, now it's playing. Now it's playing. But yeah, it just ends up with a draw and not doing. It's not. Yeah, just gonna be end as a draw, which is not the case. So yeah, we really need to. Yeah, now I'm pretty sure that we need to go for that sort of a p-square table, and we'll create a very simple one. So yeah, just grab the board. Or I even don't need to do that. So let's create the PST. So this is the p-square table. 0, 0, 0, 0, 5 to 4, 5, 6, 7, 8, 8. Yes. And so I want to encourage going to the central squares. So, well, actually, if I say we'll be trying to stick to the center, not. Well, let's say like 20, or even I don't need this. I can just say, like, let's say 9, 8, or even easier. So let's have this -1 to encourage him just going somewhere, like going forwards, basically. I want both sides trying to going forwards. 1. No, let's not make this 0. Let's make it maybe. Let's make it 4. Let's make it 8. Let's make it 8. Let's make it 4. So that's already going to be a little bit more interesting. So just very quickly grab the code for handling the positional scores, because I just generally want to spend hours for debugging this. Well, probably I still should, but hopefully we see this watching the play. That should be enough. So here, so this is the here we have the material score, and here we have the positional score. So if pace lower is pace upper, no, it's not the case. So I can use the bit number. Oh, I can actually use the colors. Yeah, I can use the colors instead. I don't even need any bits. So for black pieces, if colors indexed by the piece is equal to black, the score is equal minus equal PST indexed by the square, here plus equals, and here if colors indexed by the piece is equal to white, and yeah, this should be already enough. Yeah, it doesn't result in a better play, really. Okay. Yeah, now just okay. This is gonna be this is getting really interesting. So now just the phrase doing anything, literally. Phrase doing anything. So assuming that we have. Yeah, probably we can't just try to put the rook here because it's not gonna get captured, right? So I can try like, hold on a sec, do I really have, oh, what have I done? Just it's 8, but it should be, yeah. So first of all, it's just all run. Just all run. First of all, it's all run. I guess we need to have them 10. Okay. Yeah, now it lists. So yeah, now it's list they are 10. Okay, now it starts making kind of sort of a sense. Yeah, but still, it just doesn't just quick draw. So now. Let's say it's encouraging the rook go in here, for instance, 7, 6, 5, 4, and here in the country, so 8, 7, 6, 5, 8, 7, 6, 5. Oh, this can be the case. Nope. Yeah, let's make it 7, 6, 5. Yeah, a bit of a yin-yang here. Okay. Okay. Yeah, now the game is getting interesting. So now it's just Ken is trying to hunt. Okay, yeah, now it's really getting interesting. So yeah, the next thing to change here is the value for queen, because we can have so the value for queen can't be that big. So it's actually should be the value of rook, and the value of queen should be probably 400. So just slightly better than the bishop, because it just can go like, well, actually can try go for 500s as well. So just swap the scores for rooks, and just swap the scores for rooks, and yeah, now it looks more reasonable, and it even managed to checkmate. I didn't understand how this happened, but anyway, yeah, let's try one more time. Okay, so yeah, it's gonna run. Something is wrong with the scores. I believe something is wrong with the scores. So yeah, let's try to evaluate. So print. Actually, it's 0. Okay. Okay. Okay, let's say this is the case. So bring king in. So queen goes. Okay, so this can't be captured really. Okay, because rook protects. Okay. Now queen attacks the rook. Because it's less valuable in this game. It's reasonable. Okay, rook tries. Okay, still. Well, rook actually doesn't have any options to. So if rook went, yeah, rook doesn't have any options. It just gets trapped here. Yeah, because of it's not calculating that dip, it might be just okay. Actually, this is the stalemate. It's not the checkmate because there is no check. And yeah, I just didn't really. Well, actually, this game, the initial implementation didn't really have, yeah, the handlings of the stalemate. So actually, this is the stalemate. So as far as I didn't yet take a decision of whether the stalemate is going to be a draw or a lose. Yeah, that would change the game pretty significant. But so now it kind of tries to force the stalemate. Well, okay. Anyway, we now actually try to play this brand new game for the very first time. I just want to see how it kind of feels versus the playing versus computer. Okay, so for instance, if I just try to put my rook from b2 to f2. Okay, so brings the rook here. Okay. Now let's say bishop from b1 to c2. Just trying to bring things closer. Okay, he develops his queen. It kind of makes sense. Let's say a1 to b2, and he promotes his queen as well. But hold on a sec. Can I just grab that queen? Oh no, I can't grab. Oh, where is? Oh my God! I just blundered the rook. Whoa. Okay, I resign. Okay. Yeah, so far so good. Okay, this game is really getting interesting. So b2 goes to f2. Yeah, I think that for simplicity, stalemating the king might be left, might be considered as a win. So I really want this game to be as simple as possible, and I think this is gonna be fine. This is gonna be fun as well. Okay, so. Yeah, let's try the same game. So b2 goes to c1, and he drops bishop down. So yeah, now my rook is not attacked here. Oh, hold on a sec. Where the? Oh, b2 to c. Oh, what have I done? Yeah, I just went off board. Okay. b2 goes to f1. Nope. b2 goes to f2. This is it. Okay, now b1 goes to c2. Okay, yeah, now we have the same game. So now he's threatening to grab my rook, which I don't want to. And do I actually lose a rook here? This is really interesting. So, because do I really lose a rook? Because where do I go? So if I go here, I get captured by the rook, right? So it feels like my rook is getting into trouble. And that's the reason why the computer avoided moving like this. That's pretty smart. If I move here, well, probably the only move I can do is here. So from f2 to d2, f2 to d2 to avoid losing the rook. Now here's the rook is attacking. What is the rook does? I'm not quite sure what his rook does. Is it threatening to take anything? Doesn't seem like. So if I go b2 to d1. Oh, what if I b2 to d1? This doesn't exist. Oh, I just skipped. I meant c2 to d1. Okay, so I just gonna skip the move. Okay, c2 to d1. Yeah, if I go like this. So yeah, what I want to do, I want to checkmate the king, right? Now, for instance, I can try to. Yeah, did I capture the rooks? If I go a1 to b2, so a1 to b2, did I actually capture his rook? Yeah, so he just took my bishop, so now I'm winning a rook. This is good. So d2, nope, d2 captures to d1. Okay, so I'm exchange up. So far, so good. So I can't grab neither of these guys still, but anyway. So now the queen goes from b2 to c2. Okay. And let's bring the king in. Well, first, yeah, just probably c2 to d2. Going with the queen. Okay. Yeah, that makes sense. So now queen is attacking the rook, and actually meanwhile offering the exchange of queens. So I don't mind. So I can just say d2 grabs on e2. Okay. But why didn't he capture? I mean, was there a mate or something? Well, this is getting interesting, really. Okay, so in this case, e2 takes on f1, check. And okay, f1 goes to g1, check. Why is it? Yeah, this is a checkmate because he can't go anywhere. Yeah, this is nice. So I just I just kind of bit my own program. I don't know. So actually, if I increase the search depth, let's increase this to 5. Yeah, it's most likely would be skipping the, maybe not. I mean, skipping the moves to not going the shortest distance ever. It's hard to say. Well, okay, this time I would try to play a bit more smart. So b2 to d2 with the rook, for instance. Okay. And he doesn't even develop his rook for some reason. That's interesting. So now let's say b1 goes to c2. Okay, so he wants to exchange. Well, actually, he's threatening to take my rook. Okay, it's interesting. Let's exchange the rook. So d2 takes on g2. So taking the rook, queen takes. So far, so good. And let's say a1 to b1. So I want to bring my guys in. Let's go b1 to c1, for instance. Okay, c1 to d1. He attacks my queen now. d1 to d2. King goes. Okay. Okay, I think that king a2 goes to b1 is the case. So what did he do? Okay, he just drops back his queen. Okay, so b1 to c1. Okay, c1 to d1, and why is this a checkmate? Oh, maybe I just... Oh my god. Or I get checkmated. Hold on a sec. So plus, so this is probably... Oh my god, who has get checkmated? Who has get checkmated? Where's my king? Here is my king. Oh, there was a check. Oh man. Yeah, that's a bit unfortunate. So that was a check. That's the reason I just didn't see that. Oh, I went into the check and then, yeah, I just lost the games because I made an illegal move. Got punished for that instantly. Okay, well, okay, guys, I think this is good enough for a proof of concept, basically. And I already kind of feel motivated to actually implement this sort of a game in 6.502 assembly language and try to run this on my Kim1 emulator. So this might have made sense at some point. And I believe playing this game on the real, not on the real, but like on Arduino based emulator would be really fun. Yeah, because we really have everything to kind of play this game. There won't be things like this notation, and there would be some, I will make some custom manual for the notation, how to input the moves. But the rest of things like the score apparently might be printed at some point. Might be printed at some point. Again, without the question search, it doesn't make much sense. But yeah, it's just for fun, basically. So I think that might be just really on the cards. If I didn't use the question search for normal chess, then here definitely this can be just good enough. So yeah, I'm not trying to make the strongest game possible ever, but just want to have some fun. So yeah, by the way, these kind of patterns I've been using in this little tiny little piece of code are exactly the same patterns I've been using in my Toy Fish engine, which I consider to be the most beginners friendly chess programming tutorial I made so far. So feel free to watch that as well. There would be tons of links in the description below this video covering all the stuff I've been talking about. And yeah, I think that next I'll probably first try to implement this game in 6.502 assembly, and if it works and if I like how it looks and feels and things like that, then maybe we could have go for some tutorial series on kind of old school programming in 6.502 machine codes. Well, at least I'm gonna be coding this in 6.502 machine codes, even though I have an assembler, so I can do I can use the assembler, just assemble the codes and send Wi-Fi serial port to my Arduino, but that's just that's cheating. So I want to go the hard way, and I really want to implement all of this in 6.502 machine codes. That's what I'm interested in doing, basically. And then it works, then maybe there would be some interesting tutorials at this point. Okay, guys, yeah, this is it from my side. So thanks for watching, thanks for following. Feel free to give this game a try to play it. Let me know in the commentaries if you like the game. If you try to change the rules or something, I would be interested as well. So for now, checkmate. For now, stalemate is kind of like a win here in this game. You might be changing that. But yeah, so feel free to do whatever you want with this source code. This is it from my side, guys. Again, thanks for watching. Until the next time, and take care.